Welcome to lesson number 3. In the last lesson, we applied step number 1, which was to convert our image to grayscale. Step 2 is to now reduce noise and smoothen our image. When detecting edges, while it's important to accurately catch as many edges in the image as possible, we must filter out any image noise. Image noise can create false edges and ultimately affect edge detection. That's why it's imperative to filter it out, and thus smoothen the image. Filtering out image noise and smoothing will be done with a Gaussian filter. To understand the concept of a Gaussian filter, recall that an image is stored as a collection of discrete pixels. Each of the pixels for a grayscale image is represented by a single number that describes the brightness of the pixel. For the sake of example, how do we smoothen the following image? The typical answer would be to modify the value of a pixel with the average value of the pixel intensities around it. Averaging out the pixels in the image to reduce noise will be done with a kernel. Essentially, this kernel of normally distributed numbers is run across our entire image and sets each pixel value equal to the weighted average of its neighboring pixels, thus smoothing our image. We're not going to go over kernel convolution and how it does it. Just know that when we write this line of code inside of our editor, blur is equal to cv2.Gaussian blur, what we're doing is applying a Gaussian blur on a grayscale image with a 5x5 kernel. The size of the kernel is dependent on specific situations. A 5x5 kernel is a good size for most cases. But ultimately, what that will do is return a new image that we simply called blur. Applying the Gaussian blur by convolving our image with a kernel of Gaussian values reduces noise in our image. Back to our project, set blur is equal to cv2.Gaussian blur. We'll apply this blur on our grayscale image with our 5x5 kernel, and we'll just leave the deviation as 0. The main thing you should take away from this is that we're using a Gaussian blur to reduce noise in our grayscale image. And now we'll simply show the blurred image. If we run this code, python lanes.py, there is our blurred grayscale image. Later on, when we apply the canny method, it should be noted that this step was actually optional, since the canny function is going to internally apply a 5x5 Gaussian when we call it. Regardless, now we know the theory, we've obtained our grayscale, we've smoothened it and reduced noise with a Gaussian blur. Now it's time to apply the canny function. We'll do that in the next video.